Okay, welcome to episode 7 of the Science of Setup. This one we're going to talk about steering geometry, Ackerman it's also referred to, and also called dynamic toe. So first I want to explain on the setup tab. So to get here, if we go to the model manager, I'm using the touring car model again. We'll look at some of the other models later. Click on Setup and then click on the Steering tab to get here if you're following along. So what I want to explain is what we have, the tools that we have here to help us understand Ackerman and what the changes we make to it are actually going to do. So we've got 3 different graphs we can display here. We've got a steer angle difference. So what this is, the blue line is the actual model. It's the model that we have here, and what it is the difference in the steering angle between the inside and the outside wheel. So as we steer, you can see here that the difference started out at 2 degrees because we have 2 degree of toe angle, so we got 1 degree there and 1 degree there. So we start out with 2 degrees, and as we increase our steering angle, you can see here that our difference is staying fairly constant initially, and now it's going to start to grow as we get more and more and more steering angle. So you can just use the slider here to move it back and forth if you want, but it shows you what the difference is between the inside and outside wheel. And that's what this graph line is here. So essentially this blue line is this difference that you see here between these two, between the inside and outside wheel. Relative Ackerman, what it is, first I should say, this red line is what's called true Ackerman. Okay, so true Ackerman is the amount of steering angle difference you need between the inside and the outside wheel to negotiate a constant radius turn with 0 slip angle. You know, that's a whole mouthful of stuff, but I'll show you a graphic here in a second that should hopefully clarify it. So relative Ackerman, what it is it's the difference between these 2 lines. So you can see here that we're going along and we're very, very close to what true Ackerman is, and then once we get out to 15 or 16 degrees, then we start to deviate from it. Reason that happens is it's just very difficult to get an exact match for what would be considered the ideal Ackerman throughout the entire steering angle range. The third one we've got here is camber angle. So as you steer the wheels, because of the fact you either have kick up, in this case we have 0, and caster, you get camber change on the tires. So what this shows is, as a function of the steering angle, what the camber on the outside wheel, so on the outside wheel you're going to be increasing the amount of camber you have. So in this case we're starting at minus 1.5 and increasing. And on the inside wheel, we're starting at minus 1.5 and we're losing camber. Okay, so that explains those. The other thing that we've got here is we've got this little bar graph, and what it shows is the difference between the true Ackerman and what I've termed here pro and anti. I'm going to be changing these to more or less because there's some confusion about what I mean by pro and anti. So you can either have more Ackerman or less Ackerman than what the true Ackerman setting is. So again, what this is showing is what the steering geometry is doing, basically following this line. So as we go along here, we're staying pretty close to true Ackerman, and then all of a sudden we start going, wow, okay, and we get way out from what true Ackerman is. So that's what that bar graph is showing you. One thing you may be wondering is, well, what do you do when you're getting so far off from true Ackerman? Because what's happening is you're probably just dragging this inside wheel. Well, most cars will have some sort of a hard stop built into the inside wheel. So in the case of a touring car, it's probably somewhere in the 35 degree range. So that's about as far as you're going to get. So at 35 degrees, we've only got 25 degrees of steer angle. So we're only in this sort of range here. We're not getting all the way out to the end at this point. Okay, so what affects Ackerman? Well, the angle of the tie rods is a big one. So the more, if they point forward or pointing rearward, gives you less or more Ackerman. If you move the outside mounting point of the tie rod inward or outward, that's going to affect your Ackerman. And also the toe angle that you have is going to affect your Ackerman. So this one is set up right now with 2 degrees of toe out. So you can see we already have a 2-degree difference between our tire angles. So if I change this to 0, so we're going to just go with them straight ahead, you'll see here now that we will have less Ackerman. So we went from 10 degrees down to 6 degrees. If we change this to 1 degree, so we're going to now have toe in, you can see we've got even less. So I'm not suggesting that you should go toe in just to try and get your Ackerman angles right, because that's generally not going to work to your advantage. So I'm just going to leave this set at 0 for now. I'm just going to save that. Okay, so let's talk about true Ackerman here for a minute, just so that we can define exactly what that is. So this is our true Ackerman line here, the red line. So what I want to show is this little graphic here that shows you a vehicle that's going around the corner, which is the path is defined by this green line. So it's a constant radius turn. Now, in order to negotiate that turn, the inside tire needs to be at an angle of 36.2 degrees, and the outside tire needs to be at an angle of 26.6 degrees. That's all assuming that there is 0 slip angle between the tire and the surface that you're driving on. So, as we know, and I can hear you guys going to sleep already, from episode 1 where we looked at a tire performance graph, that if we have 0 slip angle, we have 0 lateral force. So obviously we need to develop some sort of a slip angle or the car just isn't going to turn. So we've got our little graph from episode 1 here up, and in that episode we connected the peak of all the lateral force curves together. So each one of these lines represents a lateral or a vertical force of, in the case of the top curve, it's 1,000. In the case of the bottom, it's 400 pounds. So increasing vertical force gives you increasing lateral force as long as you have a slip angle. So this slip angle here with this tire requires that the slip angle increases with increasing vertical load. You could also have a tire performance graph where the grip would require decreasing slip angle with vertical force. So it could be going in this direction. You could have a peak here and then it would decrease. So it depends, it's strongly dependent on the tire itself. So in this example, let's say that our inside tire is at 400 pounds, so we need a slip angle of about 4 degrees on our inside tire to get the maximum grip. And on the outside tire, if we say we're on the upper curve, so we're at 1,000 pounds, we need a slip angle of about 5.4 degrees to develop maximum grip. So if we go back to our little graphic here, you can see that on the outside tire, we need to add 5.4 degrees of slip angle to achieve our maximum grip. and on the inside tire we only need to add 4 degrees to achieve our maximum grip. So in the case of this tire, these slip angles would add to our Ackerman angle that we need in order to develop this grip and actually turn through this radius. So we would need 32 degrees of steering angle on our outside tire, and we would need 40.2 degrees on our inside tire. Now the important thing to note here is that the difference between these two is less. So we need less slip angle on the inside tire than we do on the outside tire. So what that would mean is you would actually need less than true Ackerman for this tire to develop optimum grip. Now the unfortunate thing is that we are never going to have these wonderful graphs for our tires that would give us some insight as to which direction we need to go. So how do we determine which is better for a particular tire? Well, the only way I can think of is you can try and do some skid pad testing. So if you set up a constant radius turn and use your timing system and try and stay on a line in the middle and adjust your Ackerman, you should be able to get some insights as to which direction the tire needs, whether it needs more Ackerman, less Ackerman, or possibly true Ackerman works the best for that particular tire. Okay, so let's have a look at what changes we can make and how much of an effect they're going to have on our Ackerman. First thing I want to do is I want to make a little change to the steering models here so we can see this a little better. So what I'm going to do is on the alternate hub point, I'm going to put an inner. So the outer point is going to be there, and I'm going to add an inner mounting point, which you see quite frequently, and we'll put it 4 millimeters inward. So if we save that, so you can see there I added this extra point, and I'm also going to add another point for the rear. I'm going to say 5 millimeter, and because the reference point here is at the 1 millimeter shim, I only need to put 4 millimeters as my offset, so there's my new point there at 5. So I'll save and exit that. So now I've got these 2 extra points, and we can close this out and go back to our setup tab, and we should see our extra points. So you can see these extra points that I just added are in here. So let's use our relative Ackerman graph, and we have 0 toe angle set here right now. So let's see what happens as we change the angles. So right now we have our arms are pretty parallel. We are at 0 shims here. So if we go to 1 millimeter shim, as we start increasing this and moving as we start moving our angle on our arms more forward, so the inner pivot point is forward, more towards the front axle, you can see here that we are reducing the amount of Ackerman that we have in the steering geometry. So if we go back to our base starting point and we do the opposite, and now we're going to have our arms pointing rearward, so we're going to move to this inner mounting point. So if we move to that, now you can see that we've increased the amount of Ackerman that we have. We have lots of Ackerman in the steering geometry now. So moving your arms so that the arms point downward or towards the rear of the car is going to add more Ackerman. If you have your arms pointing upwards, so pointing towards the front axle, you are reducing the amount of Ackerman that you have. And you can see that also if you're using the little bar graph here, you can see that we're on the less Ackerman side. Once we get to a certain point, we may, we're already limited out here. We're not. We go to 30. we can probably get this going more. 35. So you can see here that once we get out to a certain point, we're going to start going onto the more Ackerman side again, just because of the inability to get our geometry to match exactly what the true Ackerman definition is. So the other thing we can do is, let's go back to our base settings again. So the other thing we can do is we can change our toe angles. So if we go back to our relative Ackerman here, so you can see here right now we've got about 6 degrees of Ackerman out at our maximum steering angle. So if we add 1 degree of toe out, you'll see now we've got 10. If we go 1 degree toe in, now we're down to 3. So changing your toe angle makes a very dramatic difference in the amount of Ackerman that you actually have. So just be aware of that. Normally you're not going to do a setup with toe in. You're probably going to be somewhere between 0 and 1 degree toe out, and possibly even more. And one question that gets asked a lot is, why does toe out improve turn in to a corner? So what we need to do is look at our slip angle graph here. So if you consider you're going down the straightaway and you have 1 degree of toe out, your inside tire is already operating at a slip angle and it's already generating a lateral force. Now, to keep that balanced on the other side, you have toe out on the other wheel, so they're balanced out. So now, if you consider that we start turning into the corner, as we start turning into the corner, the inside tire is developing slip angle very quickly, and the weight transfer has not really occurred yet. So you still have, or the effect of that increase in slip angle versus the outside tire is to draw the car into the corner. So that, in a nutshell, is why toe out provides you better turn in. The opposite is true when you're coming out of the corner. If you get too much toe out coming out of the corner, you're actually going to end up with an understeer situation because of the toe out you've got on the outside tire, which is trying to push you to the outside of the turn. Let's have a look at some other vehicles here. Let's have a look at the Truggy. If we go into setup and steering, so you can see here the Truggy has various positions here. The 0 position is arms fairly straight. If we move to the upper position, you can see that we have much less Ackerman. We're on the negative side. If we move it down so the arms are pointing downward, then we have lots of Ackerman once we get out to higher steering angles. So yes, we still want to leave. So let's have a look at two-wheel drive buggy. So two-wheel drive buggy has a slider rack steering system. So in this one, you can see that we can get lots of Ackerman. What we can't do is we can't get less Ackerman with this setup. So the only thing we can do is we can increase the amount of Ackerman that we have. We can't actually reduce it. Not 100% sure why. I haven't really thought about it too much, but something to do with a two-wheel drive buggy, I presume. Okay, last but not least, let's have a quick look at an 8-scale on-road car. These vehicles, whoops, wrong button. These vehicles use a single bell crank, so you can see everything pivots around a center point here. Again, this has got a fair amount of Ackerman in it. If we go to the upper point, we can reduce the amount of Ackerman, but we can't really increase it beyond where we are at the initial point. So, and as the steering increases, you can see it's just pivoting around the single point. Okay, that's all I have to say for now. Hopefully I haven't put you guys to sleep, and hopefully you learned something about steering geometry and why you would want to use more or less Ackerman. Up next, we're going to be moving on to episode 8. We're going to talk about damping. So we're going to look at oil viscosity and number of pistons and or piston holes and sizes, and talk about low speed versus high speed damping. This is probably going to need to be done in a couple episodes because there's a lot of stuff to cover here. So stay tuned.